are pretty similar to equations. However, the solution should be in an interval notation. I'll explain in a moment. But inequalities use a different symbol, not the equal symbol, but the symbol that is greater than. This is greater than this, left less than right, left greater than or equal to the right, or left less than or equal to the right. So these are the inequality symbols. Inequality symbols. The inequality symbols. Okay. Here's an example. Very simple inequality. I read it. And when I read it, it states x is less than or equal to 2. On the real line, negative infinity to infinity, 2 is somewhere here. I will put it as a full point. Why am I putting it as a, or graphing it or plotting it as a full point? Because of the equal symbol. And this is 2. X less than or equal to 2 means everything from negative infinity to 2. And this is what you see here is the interval notation. The bracket is always used when there is an equal symbol in the inequality. Infinities are symbols. Infinities are always parentheses. So the interval notation is exactly what you see here. Parenthesis, negative infinity 2 with a bracket. Any questions? Now, if I'm given something like this, I read it. X is greater than negative 3. Again, on the real line, negative 3 somewhere here. I don't need units, I just didn't explain it, but I will use an open point. Why is it an open point? Because the equal symbol is not here. The open point translates into a parenthesis, not a bracket. X greater than negative 3, so this is negative 3 to the right. Everything here. And of course, the interval notation is what you see. An interval notation, negative 3 to infinity. I personally like to write x in the interval. X in the interval, so it's clear. I could also have a situation like this. The in-between situation. In between. What does this mean? Well, something like this. Greater than negative 2, but less than or equal to 4, or vice versa, or both equal, it doesn't matter. So how do I read this? In between. X is in between negative 2 and 4. So then on the real line, 0 in the middle, negative 2 with an open point, but 4 with a full point because the equal symbol is there. So 4 means a bracket, and negative 2 means parentheses, or parentheses. So then that's what I have. And I will say x in the interval, negative 2 with parentheses, comma 4, bracket. What does this mean? X is any number, not negative 2, but negative 1.999999 and to the right till including 4. What if I have something like this? How do I convert this into interval notation? Exactly what you see. X in the interval, negative infinity to infinity. The entire real line. The entire number line, if you want. Same thing. So far we looked at inequalities and we presented the solutions in two ways. Either graphing it on the real line or number line, or presenting the interval notation. There is a third one, which is not that useful, but you're going to see it in Pearson. But there is a third way of presenting solutions. So let's look at another example, and I'll show you all three ways. So let's say I have -2 less than x less than 8. Step number 1, -2 to 8. And I write x in. Because if I tell you -2 to 8, you may say it's a point. No, it's not a point in this case, because specifically that's the reason why I put x in. So it's clear this is not x and y as a point on the coordinate system. No, this is an interval for x that can be anywhere between -2 and 8, not to -2 and not 8. A second option is the graph. Here is -2, somewhere here is 8, and I graph it. And there is a third possibility, which is called set builder notation. Set builder notation. How does it look? Nothing. Braces x, a vertical bar. This stands for such as, or having the property, whichever you prefer. So it's the set of values of x, and all these values of x have the following property. What is the property? This. That x is between -2 and 8, not -2 and not 8. That is the set builder notation. Any questions? Any questions? So we have the interval notation. This is the interval notation. We have the graph. And we have the kind of a little bit of useless set builder notation. What did I do here? Nothing. I just copied this here. There's nothing to it. Something very, very important. Very, very important when it comes to inequalities. Here's the question for you. Is 2 less than 4? Is it true? Good. Let's multiply both sides by 10. Is 20 still less than 40? But what if the same inequality, 2 less than 4, let's say I divide both sides by -2. This time I get -2 on one side and -1 on the other. Can I still keep the same inequality symbol? So 2 divided by -2 is -1. 4 divided by -2 is -2. So I had this inequality symbol. Can I still keep it? In other words, I'm saying, is -1 less than -2?
No.
No. So this is something very important to remember. Every time we multiply or divide both sides of an inequality by a negative number, not by positive, but by a negative number, we must switch the inequality symbol from whatever it was before to the opposite. If it's less than or equal to, I get greater than or equal to. If it's greater than, then I'll have less than. Exact opposite. So this is a very important rule. So here it is. Switch the inequality symbol when dividing or multiplying both sides of an inequality by a negative number. Only by a negative number. We looked at a positive situation. When we multiplied both sides by a positive number, nothing happened. The inequality symbol does not get reversed. So you must reverse the inequality symbol when multiplying or dividing both sides of an inequality by a negative number. This is carved in stone, and we know why. Okay, I think we are ready now to solve inequalities. Solving inequalities. Very similar to solving equations. It's just that the symbol is an inequality symbol. So here's our first inequality. 4x plus 6 less than 6. Do not change the inequality symbol to an equation. Please do not ever do that. Okay, so what would be the first step? We are trying to solve for x. So let's solve for x. What is the first step here? Anybody? What would you do? Anybody, please? What would you do first? If you had an equal symbol instead of the inequality symbol, what would you have done first? It's the same step.
Move the 6 over?
Of course. Excellent. I bring the negative 6. 6 minus 6 is 0. Good. I have to clean it up. What would you divide both sides by to simplify it?
4.
Exactly. 4x divided by 4 is x. 0 divided by 4 is 0. I divided by a positive number. I do not switch the inequality symbol. Interval notation, negative infinity, 0. X in. Any questions? Do we understand the steps? Do we understand the solution? Yes, no? Okay. 4x greater than to 8. What will you do to both sides to solve this inequality for x?
Divide by 4?
Yeah. So we have x greater than or equal to 2. How do I write the solution? X in the interval, bracket at 2, and to the right. 2, comma, infinity. What about 4x greater or equal to negative 8? What do we need to do here to solve for x?
Same thing, divide by 4.
Good. So then x greater or equal to negative 2. So x in the interval from negative 2 to infinity. Good. Any questions for me? Good. Here's another. Negative 4x greater or equal to 8, and also negative 4x greater or equal to negative 8. Negative 4x greater or equal to 8. What do we need to do to both sides for the first one?
Divide both sides by negative 4.
Very good. So when I do that, the left-hand side is x, the right-hand side is negative 2. What do I need to do next?
Flip the sign.
Yes, from greater than or equal to less than or equal to. And now from negative infinity to negative 2, because it has to be all to the left of negative 2. X in the interval, negative infinity, negative 2 with a bracket. Very good. What about here?
Divide by negative 4.
Good. So I have x and I have 2. What happens next?
Flip the side.
Yes, indeed. From greater than or equal to less than or equal to 2. So from negative infinity to 2. X in the interval, negative infinity to 2. Good. Here's the next example. 1/2 x minus 5 greater than x plus 8. So let's see what we do here.